Okay, in order to simplify this, let's first convert the radicals to fractional exponent notation. And the fifth root is simply raising whatever the radicand is to the 1/5 power. And a square root, remember, always has a little 2 here. So it's raising the radicand to the 1/2 power. Now, in order to simplify this, to get them under the same radical, we need to have the same denominator here. So multiply times 5 on the top numerator and denominator of this one, and times 2 on the numerator and denominator of that one. The result is 2 to the third times x to the fourth raised to the 2/10 power. And downstairs you've got 2x raised to the 5/10 power. So you can think of this as being, since the nth root of a divided by b is the nth root of a divided by the nth root of b, that property of radicals allows us to think of the 10th root as having been taken of the entire expression. So 2 to the third times x to the fourth squared divided by 2x to the fifth, all of that raised to the 1/10 power, because the 10th would distribute to each numerator and denominator, then multiply times the exponents, getting what we had before. So now we can distribute the exponent in the numerator, and this becomes 2 to the 3 times 2 is 6th power, x to the 8th power, 4 times 2 is 8, divided by 2 to the 5th power, x to the 5th power. All of that then raised to the 1/10 power. Now, using that property that a to the n divided by a to the m is a to the n minus m, we can use that twice here. And this expression then simplifies to 2 to the 6 minus 5 times x to the 8 minus 5. All of that raised to the 1/10 power. And so what we have is 2 to the 1 power and x to the 3rd power, all raised to the 1/10 power. And if we write that back as a radical, we get 2x to the 3rd power and the 10th root of that. So it's the 10th root of 2x to the 3rd power. This is how our radical simplifies.